Hello, my dear lovely students. How are you? I hope you are quite well, happy, and your study is going very well. Today, we are going to study here the method of preparation of carboxylic acid from esters by basic hydrolysis. Okay, so I write here hydrolysis of esters. That means the formation of acid. Okay, here see, understand students, the ester, that the acidic hydrolysis what will form? Carboxylic acid form. Okay, and this is called hydrolysis of esters by acidic hydrolysis. Okay, see here, the R C double bond O, O R dash, and we'll take here the water in the presence of H plus, so that we'll form the here the acid plus R dash OH. Okay, you can observe here which R is here. This is the R dash. So this is the R dash, means that part will be clipped here. Okay, but through base, see, if we have the ester and if we take the basic hydrolysis, and we'll get the carboxylate ions. And this carboxylic ions, when do the hydrolysis, followed the hydrolysis, and we'll get the carboxylic acid. Okay, now you can see here the what mechanism will follow the hydrolysis reactions. Students, if you take the base, through base, I'm talking about this hydrolysis. When you talk about the base, we'll use the BAC2 mechanism. Okay, so BAC2 mechanism is what? This is the nothing but base catalyzed acyl oxygen biomolecular reactions. Okay, that is called, that means BAC2 mechanism. Okay, see students, what happened when the base promoted hydrolysis, if you will take base promoted hydrolysis, that is called saponification reactions. What? So because soap, you will get that soap is formed, that is called a saponification reaction. Let's understand through the example and the mechanism. See here, R C double bond O R dash, if you take the OH, and this is nothing but isotopes here, oxygen O18. So that will react here, and so that will form R C double bond O O. Here is the negative plus R dash OH. Okay. Now see here, and if you take here, this, uh, if you want to take that like that, R C double bond O O minus plus R dash OH and the isotopes, that's not possible, students. Okay, because isotopes will attack on the center of the carboxylate ions, so OR group will leave here, right? So that the reaction will form. So this is not a proper product. Actually, students assume that the AC ester, the acid group is very strong, so that will not be cleaved here. But that's not a true, students. Here the OR group will leave the position, so OH will attack. See, understand the mechanism. R C double bond O OR dash. Okay. So when you take the OH, now here that this position will attack here, and now what will happen? This is slow step reaction. Okay, in the slow step. So what will happen? R C O negative, and here is the OH and OR dash. Okay, this is tetrahedral, student. It is a tetrahedral intermediate. Okay, It is just like SN2 restraints. So tetrahydral intermediate, and the first step is RDS. So it is a RDS slow step reaction. Now, once the tetrahedral is formed, the OR will depart this place. So, what you can say, the tetrahedral intermediates expel an alkoxide ions. So, this tetrahedral intermediate expel the alkoxide ions and the bond will back. So, lone pair will back to the carbons. And now, what will happen? The R C double bond O OH will form. So, I hope you understood how the isotropic part will attach with the carboxylate center. And second is R O negative. What is this? This is the nothing but strong base. It is a strong base. That strong base abstract the proton from H. A strong base, what happened? Abstracts protons. Okay. Now see here, what will happen, students? R C double bond O isotropic part plus R OH will form. Now sodium will take here and that will form the R C double bond O ONE. Okay. Now do you observe one thing here? This process is not going to reversible. Why? Because once the carboxylate ion is formed, which is the highly resonating structure, so this compound will give the resonance structure. Therefore, here is it is highly stable. It is a highly stable part. Okay, this carboxylate ions is highly stable part. So it will not be reversible. So it is not a reversible. Okay. Now I give you one thing. RC double bond OR dash. Okay. Now here is that I write the star. Star matlab means the O18 is there. So that means react with the anywhere sodium hydroxide, and here is that RC double bond O Na plus R dash OH. Here is the star is there. Okay. So it means in anyhow, if you have ester, that the OR will leave the positions. And O is either the O18 or O60, does not matter, but that will leave the positions. Okay. So here I have written then R dash OH will leave the positions. So I write here one thing, the base catalyzed hydrolysis is not reversible. Why? It is not reversible because carboxylate ions formed is resonance stabilized. Okay. So this is the resonance stabilized. Now I write here rate of reaction. See here, students. Rate of reactions slowed. Why? Due to steric crowding. So due to steric crowding, the rate of reaction will slow down. Either the steric crowding in the acid part or alcohol part. The rate of reaction will slow down. See here, I write one by one. First, I write the crowding in the alcohol part. Then in second, I will write the crowding in the acid part. See, CH3 C double bond O OCH3. Student, this part is the alcohol part. So one by one, I increase the carbon so that this part will be the crowding part. It is alcohol part. Here is that CH3 C double bond O C2H5, and third is that CH3 C double bond O CH, and here is a CH3. Okay, and the fourth is CH3 C double bond O C CH3 CH3 and CH3. Okay, so this part is the most here is the most crowding part. Obviously, the crowding decreases the esterification. So first is this, that is the, and second is the most hydrolysis, and third and fourth. Okay, so we can write order like that. So I hope you understood here. The one more thing, I write the crowding in the acid part. See here, now acidic part, I make the acidic part crowding here. HC double bond O OCH3. Okay, and now this part I give the crowding area here. CH3 C double bond O OCH3, and here is the CH3 all 2 CH C double bond O OCH3, and here is the next is CH3 all 3 C double bond O OCH3. Okay, so the most crowding is that this most crowding. So here is the first is the most acidic, then second, then third, and then fourth. This is the order of hydrolysis. Now what I am telling you, students, the electron withdrawing group, electron withdrawing group increases the rate of hydrolysis. What I have written here, electron withdrawing group increases the rate of hydrolysis. See, the first is that NO2 C double bond O OCH3, and then yeah, right here Cl is the carbon benzene OCH3, and then here is that compound like that C double bond O OCH3, and fourth is that here is that I write here OCH3 C double bond O OCH3. So first is that it is electron withdrawing group. So first is the most acidic, and then this is the, and then third, then fourth. Okay. So first, second, third, and fourth. Okay. So this is the order of hydrolysis of when the electron withdrawing group increases, the acid hydrolysis reactions increases. Okay. Now I give the one example, students. Tell me what is the order of the hydrolysis. See, I write here. Arrange the following compounds in decreasing order, most reactive first I write here. Can you tell me what the order of hydrolysis reactions? Okay, see that I write the example here, option here, CH3 C double bond O NH and benzene. I write second CH3 C double bond O NH and NO2. Third I write here CH3 C double bond O NH benzene NO2, and fourth I write here that CH3 C double bond O NH cyclone. Okay, so you can see here there is the most electron with, third is the most electron withdrawing group, and then second. So third is the most, and then second because the NO2 group attached there. After third, second is there, then first, and then fourth. This is the order of hydrolysis reactions. Okay, right, students. So I hope you understood the hydrolysis of ester, right, by basic way. Next lecture we understand the hydrolysis of ester by acidic way. Okay, thank you till that. Have a nice day. Take care of yourself.